Hi, this is John Linneball from John Linneball Tutoring, and this is Barron's SAT Premium Study Guide, Chapter 6A, Basic Arithmetic. Here's my contact information if you wish to contact me. Don't skip this video. Basic arithmetic problems can be very difficult. If you do the problems in this chapter in the Barron's SAT book, you'll quickly realize that problems based on, in quotes, basic arithmetics can be very hard. Some of this is because we forget basic definitions. For example, multiplication is repeated addition. Raising a number to the nth power is multiplying a number by itself n minus 1 times. What a prime number is, 2 is an even prime number. What 0 is 0 negative or positive, it's neither one. Things like that. And some things we forget just because we don't use them. So numbers taken to a fractional or negative power. What are those? So please read subchapter 6A in the Barron's SAT book and see videos linked to this one in the pop-up cards, little banners that you'll see when I'm done recording this. So question 1, page 449. For how many positive integers a is it true that a squared is less than or equal to 2a? Well, first you need to know that a positive number is greater than 0. Again, 0 is neither positive nor negative. And solve the inequality. So you could divide both sides by a. So a is greater than or equal to 2. Therefore, 1 and 2 work, so there are 2 such positive integers. Alternately, you can just plug in numbers. You can try 1, 2, 3, etc. to find out that only 1 and 2 satisfy the inequality. So for example, 1 squared is less than 2 times 1 because 1 squared is 1, 2 times 1 is 2. So 2 squared is equal to 2 times 2 is 4, 3 squared is 9, so 2 times 3 is equal to 6, 9 is greater than 6, so it doesn't work for 3. So we know it's just 1 and 2. Question 2, page 449. If 0 is less than a, which is less than b, which is less than 1, which of the following is not true? A minus b is negative. Well, let's say b is equal to 1/2 and a is equal to 1/3. Since b is greater than a minus b has to be negative since b is greater. So if we plug in the numbers, then a is equal to 1/3, which is 2/6, and b is 1/2, which is 3/6. So a minus b would be 2/6 minus 3/6, which is negative 1/6. So it's true. And then 1 over ab is positive. That's item 2. Since a and b are both positive, ab is positive, and 1 over ab is also positive. And using the values from 1, the 1/2, and 1/3, we get 1 over 1/6, which is equal to 6. So that works. 1 over b minus 1 over a is positive. Well, since b is b is greater than a, this won't work. So using the same values as before, 1 over b is equal to 1 over 1/2, which is just 2, and 1 over c is equal to 1 over 1/3, which is 3, so 2 minus 3 is negative 1. So the answer is C and 1 and 2 only. So C, 1 and 2 only. So all right, so question 3, page 449. If a and b are negative and c is positive, which of the following is or are true? So 1, a minus b is greater than a minus c. Well, let's have a equal to negative 2, b equal to negative 1, and c equal to 1. So a minus b is a negative minus a negative, so when you subtract a negative, it's like adding a positive, so the result's going to be either a smaller negative or a positive. So using the numbers that we've chosen, a minus b is negative 2 minus 1, which is equal to negative 2 plus 1, which is equal to negative 1. A minus c is a negative minus a positive, so that means it's going to become even more negative. It'll become a smaller number. So using the numbers, we have a minus c is equal to negative 2 minus 1, which is negative 3. So number 1 is false. Number 2, if a is less than b, a over c is less than b over c. Since c is positive, dividing by c doesn't change the inequality. If it were negative, we would have to reverse the symbol. When you multiply or divide by an inequality by a negative number, you have to flip the symbol. So if it's here, it's less than, it would become greater than if we were dividing by a negative. But we're not. So using the numbers, a over c is less than b over c. So negative 2 over 1 is negative 1 over 1 because c is 1, a is negative 2, b is negative 1. So that's negative 2 is less than negative 1, which is completely true. So 2 is true. And if A and B are negative and C is positive, which of the following is or are true? So that's just the same question. This is number 3. 1 over B is less than 1 over C. Well, B is negative and C is positive, so it has to be true. And if we plug in the numbers just to check, that's 1 over negative 1 is less than 1 over 1, which makes sense because negative 1 is less than 1, which is true. So 2 and 3 are true, and C is the right answer. All right, so at 3 a.m., the temperature was 13 degrees below zero. By noon, it had risen to 32 degrees. What was the average hourly increase in temperature? So the average increase is just going to be the end temperature minus the start temperature over the number of hours. So here it's going to be 32 minus 13, because 13 degrees below zero is minus 13. That's 45 degrees, and then 12 p.m. minus 3 a.m. is 9 hours. So mostly they're expecting you to not understand that 13 degrees below zero, or to miss that. So you would get something like 32 minus 13, which would be 19, and you get 19 over 9. So you can see from the answer choices they expect you to make that mistake. Anyway, we didn't make that mistake. It's 45 degrees over 9 hours, which is 5 degrees per hour, which is C. Answer C. Question 5, page 449. If 7 to the A times 7 to the B is equal to 7 to the C over 7 to the D, what is D in terms of A, B, and C? Well, 7 to the A plus B is equal to 7 to the C minus D. So we know that A plus B has to be equal to C minus D, otherwise that equation wouldn't work. So we're going to add D to both sides, so then we end up with D plus A plus B equals C. And the reason you're doing that is when you multiply powers of the same base, you add the exponents. When you divide powers of the same base, you subtract. So you can see my video on exponents. So anyway, we end up with D plus A plus B equals C, so therefore D is going to be C minus A minus B, so you have to subtract A and B from both sides. So the answer is B. Question 6 is page 449. Question, all right, if P and Q are primes greater than 2, which of the following must be true? Well, first you need to know if any prime number greater than 2 is odd. Or you don't need to know if it, you need to know, basically just know any prime number greater than 2 is odd. 2 is the only even prime number. So 1, P plus Q is even. Well, the sum of two odd numbers is always even. You can think of it this way. The odd number, any odd number, can be expressed as an even number plus 1. For example, 3 is 2 plus 1. 1 is 0 plus 1. So any even number is 2 times some other number, or it wouldn't be an even number. So the sum of two odd numbers can be expressed as 2x plus 1 plus 2y plus 1, where x and y are some integers. So their sum is just going to be 2 times x plus y in parentheses plus 2, because these ones add together, or just 2 times x plus y plus 1 when we rearrange it. So it's even. You can try this with P equals 3 and Q equals 5, so P plus Q equals 8, which is even. That's probably what you should do on the test, is just plug in numbers, but this is so you'll actually understand the theory behind it. So number 1 is true. Okay, question 6, page 449 continued. If P and Q are primes greater than 2, which of the following must be true? So again, first know that any prime number greater than 2 is odd, so they're just asking about odd numbers in kind of a backhanded way. So PQ is odd. Well, let's take 3 and 5 again. 3 times 5 is 15, so it looks like it. And what I mean by SAT method here is that's what you should do on the SAT. Just try a few different numbers that work, that are primes greater than 2. And if they all work, it's probably true. If you want to get into the theory behind it, okay, since P is equal to 2x plus 1 and Q is equal to y plus 1, their product is going to be 2x plus 1 times 2y plus 1, which is going to be 4y squared, because that's first. Then outer is 2x, inner is 2y plus 1. Since there's a 1 on the end and all the other terms, 4y squared, 2x, 2y, are all divisible by 2, then PQ has to be odd because it's an even number plus 1. So PQ is odd and 2 is true. PQ minus, or sorry, not PQ, P squared minus Q squared is even. With P equals 3 and Q equals 5, we get 9 minus 25 equals negative 16. That's still an even number, even though it's negative. So 2x plus 1 squared minus 2y plus 1 squared is going to be 4x squared plus 4x plus 1 minus 4y squared plus 4y plus 1. So that's just going to be 4x squared plus 4x plus 1, and then we have to change the sign of everything in this last set of parentheses. So negative 4y squared minus 4y minus 1. So notice the plus 1 and the negative 1 cancel out. So then all we have is 4 times x squared minus y squared plus 4 times x minus y, and then of course plus 1 minus 1, which cancels out, so it's just equal to 4 times x squared minus y squared plus x minus y. Since x and y are even, x squared minus y squared is even, and x minus y is even. Therefore, p squared minus q squared has to be even because it's all divisible by 4 or by 2. So, well, here it's 4 and 2. Anyway, so p squared minus 4 squared is even, and 3 is true. So D, 1, 2, and 3 are correct. I put is correct. Oops. Little grammatical error there. Question 7, page 450. Questions 7 and 8 refer to the following definition. For any positive integer n, tau, that's the Greek letter tau there, of n represents the number of positive divisors of n. So positive divisors are just positive integers that go into n as factors. So which of the following is or are true? Tau of 5 equals tau of 7. Well, 5 and 7 are both prime numbers with 2 positive divisors, that is 1 in themselves, 1 and 5, 1 and 7. So tau of 5 is actually equal to tau of 7, which is equal to 2, so 1 is true. Number 2, tau of 5 times tau of 7 equals tau of 35. 35 has the following positive divisors, 1, 5, 7, and 35. So tau of 35 equals 4, because 1, 5, 7, 35, that's 4 numbers. So tau of 5 times tau of 7 is 2 times 2, which is equal to 4, so 2 is true. So number 3, tau of 5 plus tau of 7 equals tau of 12. Well, we know that tau of 5 and tau of 7 are both 2, so we just figured that out. 2 plus 2 is 4. 12 has the following positive divisors, however, 1, 2, 3, 4, 6, and 12. That's equal to 6, so tau of 12 is 6. 2 plus 2 obviously is not equal to 6, so 3 is false. So the answer is B, 1 and 2 only. Question 8, page 450. What is the value of tau of tau of tau of 12? Well, we know from the previous question that tau of 12 is equal to 6, so we need to find tau of 6. 6 has the following positive divisors, 1, 2, 3, and 6. So tau of 6 equals 4, so now we need to find tau of 4. So the positive divisors of 4 are 1, 2, and 4, so tau of 4 equals 3. So the answer is equal to 3, which is choice B. Question 9, page 450. Which of the following is equal to 7 to the 8th times 7 to the 9 to the 10th power? Well, when we multiply two powers of the same number, that is, the same base, in this case 7 taken to two different powers, or even two of the same power, if you're multiplying them, you just add the exponents. So here we have 8 plus 9 is 17. 7 to the 8 times 7 to the 9 is equal to 7 to the 17th power. So now we must compute 7 to the 17th to the 10th power. When you're taking a power of a number, like 7 to the 17th, to another power, you're taking that whole thing to the 10th power, you just multiply the exponents. So the answer is 7 to the 170th power, which must be a really huge number. Anyway, that's choice C. Question 10, page 450. How many integers are greater than negative pi and less than the square root of 2? Well, integers are positive and negative whole numbers, and also 0. So, okay, got to include 0. Since negative pi is approximately negative 3.14, negative 3 is the first integer larger than negative pi. Since square root of 2 is equal to 1.414, roughly, the largest integer smaller than the square root of 2 is 1. So then you just can draw a little timeline, go negative 3, negative 2, negative 1, 0, and 1. So that's 1, 2, 3, 4, 5. I think the first time I did this, I did actually forget 0, so it's not bad to put your brain into low gear and actually draw a little graph or actually write down the numbers. So the number of integers is 5, which is choice C. Question 11, page 450. If 0 is less than x, which is less than 1, which of the following lists the numbers in decreasing order? Well, when 0 is less than x is less than 1, you have some sort of fraction that is positive between 0 and 1. And here's where we enter the upside down, like Stranger Things, where normal rules don't apply. For example, the square root of x is 1/2 when x is equal to 1/4. Why? Because 1/2 times 1/2 is 1/4. So the square root is actually larger. That doesn't apply to numbers that are bigger than 1. So the same applies to a, even if we don't have a calculator. So also, you know, basically also x, well, I guess instead of the same applies to a, it should be the same applies to x. So also x squared is less than x for similar reasons. So we know that the square root of x is bigger than x, and x squared is going to be even smaller. So we have 1/2 squared is 1/4, 1/4 squared is 1/16. So we have to list x, x squared, and the square root of x in decreasing order. Well, we already know the square root of x is the biggest, so then decreasing from that is going to be x, and decreasing from that is x squared, because it's like 1/2, 1/4, 1/16. So check if x is 1/4, x is 1/2, and x squared is 1/16. So the proper order is square root of x, x, and x squared. So the answer is choice A. Question 12, page 450. At Kathy's Candy Shop, 25.5 pounds of chocolate are being divided into gift boxes, each containing 100 grams of chocolate. To the nearest tenth, how many ounces of chocolate will be left over when there isn't enough chocolate to fill another whole box? 1 pound is equal to 16 ounces, and 1 pound is also equal to 454 grams. So the first thing we must do is convert 25.5 pounds to grams using the conversion factor they gave us. Don't use your own factors such as 1 ounce is approximately 28 grams, etc. That will give you a slightly different answer from rounding, but it's enough to make your answer wrong. Trust me, I tried it, it didn't work. So the number of grams is 25.5 pounds times 454 grams per pound, which is equal to 11,577 grams. Use your calculator. It's unlikely that they're going to give you a problem with numbers this ugly on the non-calculator section. So literally, we can get out our calculator and go 454 times 25.5, boom, 11,577. Okay, so then here's the problem again. All right, so we have to divide this 11,577. I shouldn't have turned off my calculator. Okay, so anyway, 11,577. We're going to divide that by 100. Okay, so we have 115.77. So there's 115 whole 100-gram boxes of chocolate. We don't care about that, so we're just going to subtract out the 115. And we have 0.77, multiply that by 100, and boom, we get 77. So that is, we have 77 grams of chocolate left. So 77 grams. Okay, we have to convert that back to pounds, so we're going to have to divide that by 454 grams per pound. Boom, which is approximately 0.1696. You can see it here, 1696035, blah, blah, blah. So that probably goes on forever to the horizon. Anyway, so then we're going to multiply that by 16 ounces per pound. So that's 16, so that's 2.71365, blah, blah, blah ounces. So there's room to grid in 2.71, and if we were rounding it to the hundredths, that would be correct. Do we do that? No. The instructions say to the nearest tenth. So it has to be 2.7. If you grid in 2.71, even though it's a more accurate answer, if they told you to the nearest tenth, it's the wrong answer. So make sure you read instructions, pay attention to units, etc. Okay, let's move on to the next question. Question 13, page 450. Maria has 2 electronic beepers. One of them beeps every 4 seconds, the other beeps every 9 seconds. If they are turned on at exactly the same time, how many times during the next hour will both beepers beep at the same time? Well, hopefully she's in a room by herself, or the question would be, how long before somebody takes the beepers away from her, or smashes them, or the teacher comes and says, hey, turn those things off, we're in class, etc. So, anyway, first, we must find the lowest common multiple of 9 and 4. Since 9 is equal to 3 times 3, and 2 times 2 equals 4, there are no common factors, just a 3, 3, 2, 2. So the lowest common multiple is just 9 times 4, which is 36. So the beepers beep simultaneously every 36 seconds. There are 60 seconds in a minute and 60 minutes in an hour. So the number of seconds is 60 seconds per minute times 60 minutes per hour, which is 3,600 seconds per hour. So there are 3,600 seconds in an hour. 3,600 seconds over an hour is equal to 1 beep over 36 seconds equals 100 beeps per hour. So it beeps 100 times. Okay, sneak preview of the next question. Okay, anyway. Question 14, page 450. If -7 is less than or less than or equal to x, which is less than or equal to 7, and 0 is less than or equal to y, which is less than or equal to 12, what's the greatest possible value of y minus x? Well, for y minus x to be at its greatest or maximum, y must be as large as possible, right? Because you want to subtract as small a number as possible from as large a number as possible. So x must be as small as possible. So you can set y to its maximum, which is 12, because it has to be less than or equal to 12. And the smallest value of x is negative 7, because it has to be greater than or equal to negative 7. So 12 minus 7 is 12 plus 7 equals 19. There's your answer. Only way you could really get this wrong is just by not understanding these things or reading it too quickly, not paying attention. So understand what less than or equal to means, understand that subtracting a negative is like adding a positive, etc. Question 15, page 451. If x is an integer less than 1,000 that has a remainder of 1 when it is divided by 2, 3, 4, 5, 6, or 7, what is one possible value of x? This problem is impossible if you don't really understand what a remainder is. So I know most of you probably really haven't done division with remainders since you're in maybe 4th or 5th grade, or maybe some specialized math that you learned. So anyway, it's the difference between the number you are dividing into, which is called the dividend, and the greatest whole multiple of the divisor, so the number that you're dividing by. So x is going to be a number that's one more than a number that has 2, 3, 4, 5, 6, and 7 as factors. That is, you multiply 7 by some number, you can get a number that's one less than x. Same thing with 2, 3, 4, 5, 6, and 7. So you might ask, well, John, hey, why don't we just multiply 2 times 3 times 4 times 5 times 6 times 7 and just add 1? Because 2 times 3 times 4 times 5 times 6 times 7 is equal to 5,040, and adding 1 makes it 5,041, which is much larger than 1,000. And we can even do that with the calculator. We can go 2 times 3 times 4 times 5 times 6 times 7 is 5,040, and we add 1, boom, 5,041. Okay, so that's not the way that we're going to be able to do it. So we have to find a number divisible by 2, 3, 4, 5, 6, and 7 that's less than 1,000. Well, what we can do is we have some extraneous factors. We have some factors we just don't really need. Because 2 and 3 are both factors of 6, so you could just take out 2 and 3, just go, you know, wah, wah. And 6 already has 2 and 3 as factors, so you already have a 2 and a 3. They're just put together in a 6 here. So we go 4 times 5 times 6 times 7 is 840. Again, I would suggest you use your calculator. They're probably not going to make you do this by hand. So 4 times 5 times 6 times 7 is 840, and then you have to add 1. So 841, that satisfies it. It's less than 1,000, so that works. And if you're really slick, you might say, well, hey, John, there's a 4. That's 2 times 2. But there's already 2 in the 6, so really we don't need a 4 to get 4. We can just have 2 times 5, because 6 is 2 times 3 times 6 times 7, and you would be right. So that's 420. You add 1, you get 421. That works perfectly fine. So that gives you 421. 841 or 421 would both work. On the grid-ins, you can actually have more than one acceptable answer. Sometimes you just have to put it within a range. And question 16. Page 451. What's the value of 2 to the 4 over 2 to the minus 4? And yes, I used the slash symbol instead of that little division symbol because I couldn't find it. So anyway, when dividing powers of the same number, we subtract. So it's going to be 2 to the 4th minus, well, 2 to the 4 minus minus 4. So that's going to be the same as 2 to the 4 plus 4, which is 2 to the 8th, which is equal to 256. So if you don't know that, you can put it into your calculator, assuming it's on a calculator section, and you just go, okay, we're going to need the scientific one for this. So we're going to need 2 to the 8th is 256. It's a really good idea to know the powers of 2 up to 2 to the 10th, so you can do these problems more quickly, or at least know enough of them that you can just start multiplying. Like, let's say you only knew, I don't know, 2 to the 5th is 32. It is. And then you could go, oh, okay, I'll multiply by 2, get 64. I'll multiply by 2. Okay, that's 128, so I have to multiply one more time. 256, so just keep track of that. Anyway, if you're watching this, you're probably in the Bay Area in California, so hey, honor Silicon Valley, which probably directly or indirectly pays for you to go to school and everything like that. So know that 2 to the 10th is 1 kilobyte or kilo whatever, so it's going to be 1024. All right. Question 17, page 451. What is the value of -2 minus 3? Okay, what is the absolute value of -2 minus 3 minus, in parentheses, 2 minus 3? Well, okay, you want to use PEMDAS, which is please excuse my dear Aunt Sally. That's the mnemonic. Maybe Aunt Sally is one of the, maybe that's one of your grandparents' kids who was actually born after you were, empty nest syndrome and all that. I don't know why you would want to write an excuse for Aunt Sally. It seems like if she's your aunt, she should be able to write her own, but maybe she's one of those aunts that's younger than you, or maybe she's a little, shy of a full load, so, you have to make excuses for her. But anyway, getting back to this. Parentheses, exponents, multiplication, division, addition, subtraction. So please excuse my dear Aunt Sally. Get it? So when you do that, you want to do multiplication and division from left to right, and you want to do addition and subtraction from left to right. It's not do all the multiplication, then do all the division, then do all the addition, then do all the subtraction. These two go together, multiplication and addition subtraction go together. But I digress. We really only just need to use parentheses and exponents, and okay, I guess fine, subtraction and addition. So in parentheses, -2 minus 3, that's -5. And then 2 minus 3 is going to be -1. So we have -5 minus -1. When you subtract a negative, it's adding a positive. So that becomes -4. So then we take the absolute value of -4. It's just equal to 4. Grid that in. Question 18, page 451. What's the greatest prime factor of 132? You have to do the prime factorization. So luckily 132 is an even number, so when in doubt you can just divide by 2 and see what happens. Well, 132 divided by 2 is 66. I can even do it for you on the calculator if you like. So this is 132 divided by 2. That's 66. Okay, 66 is divisible by 11. How do I know that? Because it's a 2-digit number where the 2 digits are the same. That's always a multiple of 11. So I can just divide that by 11 and I get 6. So definitely the largest prime factor is going to just be 11. So grid in 11. Question 19, page 451. If the product of 4 consecutive integers is equal to one of the integers, what's the largest possible value of one of the integers? Well, you have to play around with this one a little bit. There's really, the mathematical way you could possibly do it is big and ugly, and it's a lot easier if you just play around with it. You can just plug in numbers going 1 times 2 times 3 times 4 is equal to 24. So that doesn't work because 24 is not equal to 1, 2, 3, or 4. So this is about when I first did this problem. I said, well, okay, what if I start with -1? Well, -1 times 0. Oh, I get it. Now it's 0. So that's so the whole product's equal to 0. So if 0 is the smallest number, then you have 1, 2, and 3 as the consecutive integers. So the largest is 3. So grid that in. That's just kind of a little creativity test. Question 20, page 451. If x and y are positive integers and 13 to the x to the y equals 13 to the 13, what is the average or arithmetic mean? They mean the same thing. Ha ha ha, no pun intended, but there it is. Anyway, x and y. Of x and y. So by the rules of exponents, 13 to the x to the y is just 13 to the x times y. Therefore, 13 to the x times y is 13 to the 13. So x times y equals 13, and since they're positive integers, either x or y is 1 and the other one is 13. We don't know which out of x and y is 1 and which is 13. Doesn't matter because we just add those values together. 1 plus 13 is 14, and then we divide by 2, so we end up with 14 over 2, which is 7. So grid in 7. So we're at the end. For the best results, use the Barron's SAT 30th or 29th or even the 28th edition of Barron's SAT. This video, in case you haven't figured it out by now, covers pages 449 through 451 in the 30th edition of Barron's SAT, either the Premium SAT Study Guide or just the normal 30th edition. The page numbers are the same in the 29th edition, and they're identical or they're close enough in the 28th and previous editions. I believe the 28th edition is what's called Barron's New SAT, which came out in late 2015 or early 2016, to prepare for the in quotes, new SAT that came out in 2016. Not everything in the book is in these questions. Please really do get a copy or an e-copy of this book. You can get older editions of the Barron's book cheaply, if not for free, from used booksellers, kids who've already taken the test, public libraries. A lot of times they sell these things literally for a dime. I have bought SAT books for a dime from Bay Area public libraries. And if you plan to use a library copy, one that they're not selling, then definitely start early. There's nothing worse than feeling, oh, I need this library book, but someone else checked it out. And it's also nothing worse than trying to buy a review book that's sold out. And, it's 3 days before the test, and even with 2-day shipping from Amazon, you'll at best get 1 day to study. Yeah, don't do that. So, did you find this video useful? If you did, please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Well, why do I care? Well, it's simple. YouTube does not let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't really have anywhere near 4,000 hours of watch time the last year. I'm closing in on 1,000 subscribers, but I'm still far enough away that I need you to subscribe if you can. And for the same reasons, you are not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I do reserve the right to delete comments from and block those who specialize in destructive criticism, trolls, or things that are off topic, spammers, disturbed people, whatever. There's always somebody who thinks their comments are so important that they're even important in forums or fora, I'm not sure what the plural is there, that they have to post it everywhere they can. Please don't do that. Contact me. You can contact me on my cell phone, 415-623-4251. You can text me if you want. You can call me if you want. Email me at john@johnlinneball.com. You can mail me at 1859 Powell Street, number 109, San Francisco, California, 94133. And if you have a copyright issue, I deliberately skipped this because I think it needs to go at the end. If you think I used your copyrighted material, please contact me. I don't think I've used any copyrighted material. I don't think I've used anything that isn't completely fair use. But in any event, thanks for watching. And you can contact me on Facebook and Instagram. My Facebook is www.facebook.com/Linneball Tutoring. Instagram, it's instagram.com/john.linneball.tutoring. My home office is 415-986-7355. And email is john@johnlinneball.com. Website is also johnlinneball.com or johnlinneballtutoring.com. And I have a page on locals.com. It's testpreparation.locals.com. So hopefully you'll enjoy that. Have a good day, night, whatever time it is there. Thank you.